Hi, my name is Greg. Quick show of hands. How many engineers that have to do anything with DevOps? How many DevOps entrepreneurs? Perfect. We got 2 people I can talk to. All right, today we're going to talk about decentralized future of cloud infrastructure. This is so much better. Basically, the format is I'm going to give the layout of the land. I'm going to time myself here so we're having time for questions and walk you through where we are, where we're going, and what we could do about the current state of infrastructure. My background, I am an open source developer. I've written a few libraries that got adopted by Kubernetes, Ubuntu, a whole bunch of things. I mostly write in Go. I've been doing infrastructure automation code for about 8 years, and the last few years I've been primarily focusing on developer experience. So I take my pride by designing interfaces that are easy to type. Very few people in the world that do this, and I'm proud to be in that club. And I've been working with Kubernetes for, let's say, about 4.5 years, right before they launched, so right before Docker existed. And I love infrastructure, and I work at Overclocked Labs. So I'm just going to go ahead and say this. I think centralized cloud is the biggest threat to the future of a society. How many here agree with that? Nobody. I want to make sure you do by the end of the talk. Why? Let's look at what happened. How did we get where we are, right? Centralized cloud is great. I mean, they offer flexibility, and they get the cost efficiency by being extremely efficient by building hyperscale data centers. I mean, small number of data centers that have huge capacity, not necessarily the best performing in terms of global latency, but definitely hyperscale. And by maximizing the local, they achieve these cost advantages. And also, for the first time, we saw infrastructure on an API. That's why we're here. That's why we have our jobs. It's great. Programmers can now automate infrastructure, and they did a great job for society. Now, if you look at where they are, in 2 years from now, majority of the internet will come from cloud infrastructure to be specific. About 53% of global data center traffic will be from 3 major providers. And the market is amazing, $71 billion. That's pretty much, I would think, pretty much more than half the IT spend. So cloud is here to stay, cloud is here to take over, and 3 companies are going to control majority of the internet. So just so you know, I'm going to put it out there. Why that's bad? Why that's bad? Because if you look at the major revenue streams for these companies, right? They follow a model called burgers and fries model. They give you compute for cheap, but they charge you for other things that are not compute. They have to give you compute for cheap because they want you to buy in. And if you look at majority of the revenue stream comes from value-added services. For Google, it's Google Data Proc, which is essentially Databricks Spark. Databricks created Spark, they work on it, they evolve it. Google white labels it, calls it their own. Google has a major uptake when it comes to, or major advantage when it comes to infrastructure and cost. So Databricks does not make anything what Google makes on Dataproc. Similarly, you see with Redis, with Amazon Elasticache, and so on and so forth. Amazon has about 200 services. And I don't know how many of you actually tried to pitch a VC an open source project. If you did, the biggest question they're going to ask you is, what are you going to do with the Amazon problem? I bet you have no answer. So what we're seeing today, because of the cloud adoption, it basically took away one one of the most important monetization mechanisms that open source had, which is hosted model. You cannot do that, and that's terrible for most of us. And if you look at the centralized cloud is the biggest benefactor of open source software. How many of you know what Amazon does from an open source standpoint? How many Amazon open source projects have you used? Anybody? Right? Which one? Bodo, you use that? Yeah, one person used one project here. But effectively, that's basically where we stand. They're one of the biggest benefactors of open source software. They don't really contribute that much. And if you look at what that does to the industry, it thwarts opportunities. It's terrible. And if you look at the future we're at with centralized cloud, it's monopolized. They control prices. It's unreliable. He was talking about how a developer, having a bug that pushed to Amazon that took down half the internet, and I couldn't get my lunch that day on Caviar. I couldn't push my code to GitHub. We all know what happened. That's what happens when you have power aggregated in one or two players. And they're inefficient. They lock you in. With increased codification of infrastructure means you got to write code in order to switch. It is a project, a big, huge project. It's no longer just putting your infrastructure out there, but also automating it and testing it, make sure it's reliable. So with all the options that we have with the cloud, these are one of the key problems that we see with the centralized model today. But if you look at what's out there in the industry, right? I mean, we do have capacity. There are about 500,000 data centers that are being utilized only 15% of the time. That means 85% of the majority of the global compute power is sitting there drying in the sun. Why don't we bring that capacity to the market? This is fundamentally wrong. If you look at centralized cloud today, it reminds me of the Industrial Revolution, right? So Industrial Revolution obviously moved the society forward, but also created vertical industries. That means you end up with U.S. Steel pretty much controlling the entire supply chain, all the way from miners to transportation to the railroads, the whole shebang of it. If you look at the numbers today, 60% of the entire IT spend is controlled or is managed by cloud providers, the hyperscale providers. So the future of computing is at risk when 3 companies control the industry. That's what we're facing. And at Overclocked Labs, our mission is really to build protocols and tools and infrastructure that make the foundational elements of the internet open, decentralized, and safe. We started this company about 2.5 years ago with this mission, and we built Photon. So Photon is an open marketplace, a decentralized marketplace that connects companies with slack capacity with users that need it. And Photon also provides tools to configure, deploy, monitor, and manage your workloads. And the way it works really is the customers or the tenants come to the network. It's a decentralized network. There's no central place you go, but it runs on a blockchain. So customers come and specify their needs in a manifest file called SDL, or stands for Stack Definition Language. You can pretty much define your topology, your latency requirements, your data residency requirements, your quality of service and whatnot. And this file, this kind of looks like a HCL, that uses an HCL format, and also stake tokens basically specify how much you're willing to pay for running the job. That goes on an order book on the blockchain, and then the providers get to bid on the order, and if there's a match, there's a lease that gets created. Now, important thing to note here is the tenant, when they post this manifest, they also stake tokens. That means they put the tokens into the chain, into an escrow account, and the providers stake tokens as well. They basically proposed something called a collateral. A collateral is later used to ensure the provider is providing the resources they promise to provide. Now, once the match happens through a bid and ask process, the network creates an overlay secure network using a peer-to-peer protocol, basically based on BitTorrent, which is a little bit security mechanism on top of that, and the client's assets is then transferred to the providers. And the assets could include the Docker containers, to the private keys, to data, whatnot. So there's really no touch point that you go to. And since this is a BitTorrent network, the moment a new provider comes online, their assets is transferred as well to the provider using a torrent network that's only accessible to the client and the provider. So the way the blockchain looks really is the tenants write to the chain, post a bid, stake tokens, providers read from the chain, post their bids. Once there's a match, overlay network happens, and once the deployment is running, the network sends random checks to providers to ensure that providers are providing the resources they pledge to provide. If not, the collateral gets taken away. So that way, we ensure trust no matter what happens on the blockchain. And new blocks are minted using a new consensus algorithm called delegated proof of stake, which basically is a much higher performing consensus algorithm. It's similar to Raft, if you're familiar with the consensus algorithm. There are leaders that get elected, and leaders draw the consensus and write to the chain. So it's much faster than the traditional proof of work or proof of stake models that you have going on with the current blockchain projects. And of course, delegates get rewarded in tokens for their efforts, which is basically paid from the transaction fee. If there's a good case where providers provided what they said they're going to provide, the tokens are then transferred from the escrow account to the providers. If there's a false case where providers did not provide what they promised to provide, the collateral and the tokens go back to the customer. This is effectively how it works. And this is made possible by using an operating system that we've been working on for the last 3.5 years or so called DISCO. DISCO stands for Decentralized Infrastructure for Serverless Computing Operations. It's a container-native serverless operating system which manages the entire application lifecycle. The providers need to install this on their nodes, and the node becomes part of the network, and the operating system handles all the way from the kernel, isolation, security, to the protocol infrastructure in order for the node to participate in the network. Self-healing, auto-scaling, and fully fault-tolerant based on Kubernetes. So we extended Kubernetes to be more global aware, latency aware. And as you may understand, Kubernetes model really doesn't fit the bill if you've used Kubernetes on a global scale. Disco kind of solves that problem as to how can you deploy Kubernetes in a global scale across data center boundaries. If you look at why this is important, now we see these models happen before. In the 60s, the model was centralized, basically with the mainframe model, where mainframe had all the power, clients would go to the mainframe in order to use it. And then in the 80s, we saw the rise of PCs, which kind of distributed the power a little bit with the PC and the server almost having the similar capacities, but server being the centralized hub where the PCs could go and coordinate. But most of the work really happened on the client. And then we saw the rise of the public cloud with the evolution of mobile phones, where the mobile phone was a very thin layer, the access layer, to this centralized thing called a cloud. And now we are seeing a model going back to the decentralized model with projects like ours and others out there, Golem, Filecoin, and storage, and all those projects that are addressing each parts of the stack. And we took an approach of addressing the entire generic workload model. That ends my presentation. You can Find out more details in the white paper, photonnetwork.org/paper. You can talk to me, reach out to the team on Telegram channel. T.me, Photon Network. My name is Greg Osuri. You can reach me on Twitter at Greg Osuri.